So let's talk a little bit about insight. Some really interesting early work was conducted by this guy, Kohler. He was a Gestalt psychologist who was interested in trying to figure out how people make sense of the world they see. And for some reason that's not entirely clear, he ended up on the Canary Islands studying a group of chimpanzees. Chimpanzees are not native to the Canary Islands, so there is some controversy about why he and they were there. But nonetheless, his studies were really interesting. Basically, he watched how chimpanzees tried to solve problems. And the problems were generally about accessing food. So he would tie some bananas up on the ceiling or hide some peanuts just out of reach of the monkey's grasp and see how the monkeys managed to figure out how to get a hold of the food. And what he found is that the chimpanzees did not solve the problem of how do I get this food by trial and error. Instead, it looks just like people with insight problems. In other words, they'd try a bunch of different things and it generally wouldn't work. And then all of a sudden, it was like they got this idea in their head. Boom. And from that point on, it was as if, and we assume this really is what is happening, the chimpanzees knew how to solve the problem and just marched right towards a solution to that problem. There's some classic videos I want you to see. We'll just take a minute here and watch one. Check it out. So here's a video of one of Kohler's monkeys, and you can see, smart little guy, he's figured out that he can reach a banana on the other side of the fence if he uses a stick. But there are other bananas that are farther away, and this guy figures out if I can make this stick longer, I can get those more distant bananas. He intentionally, and in a very driven way, figures out how to put those sticks together so he can get the banana. Here, a banana is hanging from the ceiling, and you can see this guy is sort of stumped right now. How am I going to get the banana? But then he realizes, oh, if I keep piling these boxes, bingo, I can get the banana. Very intentional. Here's another one. Different group. It's like, okay, that box thing worked. Let's try that again. Oh, the guy comes over with a stick. Maybe we can use the stick in a box to get the bananas that are hanging at the very top of the screen. And they're trying more things out. Well, that didn't work. Maybe a different stick. Here, give me that stick. Let me trade sticks with you. And he trades sticks, gets a bigger stick, and watch this. Whoop. Nope, this stick. Here it comes. Boom, got the bananas. Interesting, no? Returning to humans, Janet Metcalf at Columbia University conducted some really interesting studies to show that insight problems really are different. And one of the things that she asked people to do was to solve a problem called the cheap necklace problem. You're given pieces of a necklace, and your task is to figure out a way to open and close links so that you can take these pieces and form one complete necklace out of it. But there are constraints on how you can do that. So Metcalf had her subjects try to solve the cheap necklace problem, and every few seconds, every 15 seconds, she would ask people for a warmth rating. In other words, how close are you to finding the answer? Are you there yet? Are we there yet? And Metcalf found a couple of interesting things. So did subsequent researchers. One of the things she found is that consistent with our personal experiences of insight problems, you don't really know when you're close to solving them. You try different things, right? An insight problem, and you're watching TV and poof, the answer comes to you. Or you're going for a walk or you're grocery shopping and poof, the answer comes to you. If the answer just appears like that, then if you ask people for these warmth ratings, there should be a big jump in the warmth ratings associated to insight problems right at the very end, just as people are figuring out the solution. And that is what she finds. So when she compares the warmth ratings of people who were completing non-insight problems, like mathematical equations that you just sort of plug and play, there's no real creativity involved, with insight problems, what she found is with insight problems, people didn't know if they were getting closer. And then the last 10 seconds, poof, all of a sudden they realize, Okay, now I'm warm, now I've got it. So it's consistent, Metcalfe's work is consistent with the idea that insight problems involve sudden insight, eureka moments, an immediate or sudden recognition that you've solved the problem. And usually that involves thinking about the problem in a new and different way. But there's another effect I want to tell you about with this cheap necklace problem, and that is incubation effects. It turns out if you're stuck trying to solve a problem, ironically, one of the best things you can do is to walk away. It turns out if you give your brain a chance to kind of work it out without your direct intention, you're more likely to solve it. What do I mean by that? Well, this cheap necklace problem is hard to solve. And in one study, they had people work for 30 minutes continuously to try to solve the puzzle. And when they do that, 55% of people can solve the puzzle. But if instead of working for 30 minutes straight, they had subjects work on the problem for 15 minutes and then do something else, take a half an hour break or a 4-hour break, something else that was unrelated to the cheap necklace problem. And then they had people come back sort of with fresh eyes to the cheap necklace problem for another 15 minutes. So 15 minutes, do something else, another 15 minutes, so you still get the half an hour. If you take a break, subjects were 85% likely to solve the puzzle. In other words, there was a big jump. Taking a break or doing something else can dramatically improve the chances that you have to solving a problem. So if you're stuck trying to figure out some problem at school, or maybe you're applying to graduate school and you're trying really hard to figure out how to write that personal statement, work on it for a while, work on it for a good chunk of time. But when you're stuck, go do something else. Go for a run, do the dishes, anything, something else, clean the house, and then come back and work on it. And you'll be more likely to solve the problem. The incubation effect works like this. If we take that arrow as a timeline, at the beginning, you work on a problem for a while, you're unsuccessful, then you take a break and you do something else, then you come back to working on the problem, and in that period, when you come back, you have an insight, a eureka moment, a point where you say, I've got it figured out, and you solve the problem. That's the incubation effect. That's it.